I welcome you students back for another amazing and important class and session on atoms and molecules. We have been discussing, last time we have told you very important concept, atomic mass. What is atomic mass, student? Mass of an atom. And we have shown you the atomic mass of different elements. And what scale we used for defining atomic mass. What is atomic mass, student? For a recap, what is atomic mass? I'm just giving a recap or a revision, student. What do you mean by atomic mass? Tell me.
Sir, it is the mass of the atom, which is compared to the
Related to? Related.
1/12 of the mass of carbon 12.
Okay. And according to IUPAC, what unit we use? U. U, 1U. That is atomic mass unit. The symbol is atomic mass unit is U, right? And
Yes, sir.
do you know, you are saying it is equal to 1/12 of the mass of carbon 12. Carbon 12. Okay? 1/12 the mass of the carbon 12. That means for carbon 12, we are saying it is 12U. Now, can you tell me what is the value of U in grams? Do you know what is the value of U in grams, student? 1U is equal to how many grams? It's a very, very small value. You know, the atoms are very, very small. The mass of an atom is very, very small. And when we compare different mass of different elements, you are using a scale atomic mass unit. So when I write, for example, if you say the mass of hydrogen atom is 1U, this is the mass of what? This is the mass of one hydrogen atom. Am I right? Mass of one hydrogen atom. Is it clear? When I say for we defined molecular mass also, we defined atomic masses, then we also defined, student, molecular masses. Did we define that?
Yes, sir.
What is, how do you calculate the molecular mass? By adding the atomic masses of different elements which are present in a given compound, right? We also defined the formula mass for ionic compounds. For water, you are saying, if I say H2O is water, students, what is the molecular mass of one molecule of water? Molecule. I say one molecule of H2O. How much is that? 2 plus 16. How much is that? 18. What do I write? 18U. That means, student, what we are talking here, mass of one atom, mass of one molecule. If I take carbon dioxide, for example, student, what will be the mass of one molecule of CO2? I'm saying one molecule of CO2, students. What will be the mass? I give you 1 minute to answer the question. What is the mass of one molecule of CO2 in terms of atomic mass units relative to the mass of carbon 12 taken as 12 units? What will be the mass of one molecule of CO2, students? What is the value coming?
44.
44. And what if we write 44U? Why do we write
Yes,
U?
sir.
What U means? This is the mass of one molecule of CO2. Okay? Mass of one molecule. There is a one molecule of CO2 mass is 44U. But student, this is a very small number. Let me see what is 1U equal to. That numbers which we are using in our daily life, students. What type of number you are using? You are familiar with kilograms, you are familiar with grams. But if I say U, are you using U in your daily life? The answer is no. But why? What is 1U equal to? Can you tell me what is 1U equal to in grams, student? Same definition. What is atomic mass unit? How much it comes? You have 1 minute to answer the question. What is 1U equal to in grams, students? $1.66 approximately. I'm saying 1.66, student, into 10 minus 24 gram, which can be written as 1.66 into 10 minus 27 kg. Can you see this number? How small is this number? If I'm saying the mass of one hydrogen is 1U, what is that equal to? 1.66 into 10 minus 24 gram. So is it a convenient number for us? Tell me. Can we use this?
No, sir.
This number, can I use this number? Can I wait? Do I have anything to weigh such a small thing? So this number is not convenient at all because the value is very, very small. If I say carbon dioxide is 44U, means what? What you are saying is 44 into 1.66 and to 10 minus 24 grams. This is again a very small number, very small number. So what we do in chemistry now? What we do in chemistry, what we study in chemistry, student, we are doing what we are doing in chemistry. We are doing chemical reactions. Am I right? Yes or no?
Yes, sir.
What is a chemical reaction, student? What is a chemical reaction in chemistry? There are reactants. They react to form products. For example, I write a chemical reaction here. I am saying hydrogen is combining with oxygen to form H2O, student. To balance this, there are two oxygen. There is one. So what I have to do, I have to put 2. That means 2 hydrogen. Now this is a chemical reaction. Is it a chemical reaction? Yes or no? Tell me.
Yes, sir.
Now,
yes, sir.
When I am doing a chemical reaction, I will need some calculations. What calculation? How much of water is produced by hydrogen and oxygen? And you are saying, according to this equation, which is balanced, this is a balanced equation. Balanced means, student, number of atoms on the left side of each atom is equal to number of atoms on the right side of number of atoms on the right side. This is a balanced equation I am saying. How many atoms of hydrogen are here? 2 and 2, 4. Here 2 and 2, 4. How many oxygen atoms? 2, and here 2 oxygen. Is it balanced? Yes or no?
Yes, sir.
All right. Be with me. Try to understand everything. Now, student, if I say H2 is a molecule or an atom? When I write H2, student, what it is? It is a molecule or an atom? Hydrogen is an atom.
Yes, sir.
And when two hydrogen atoms combine, they form a molecule of the element. And here I am saying two molecules. But I am saying two molecules of what? Of hydrogen. Of H2. Two molecules of H2 I am saying, not H. Are combining with one molecule of oxygen. Am I right? To produce what? What they are producing? Two molecules of what? H2O. Is it right?
Yes, sir.
Okay. You are saying two molecules of hydrogen are combining with one molecule of oxygen to produce two molecules of water. Now, if I use the atomic mass scale, student, tell me what is the molecular mass of hydrogen here? What will be the molecular mass? If I write now in terms of molecular mass, tell me what will be the value here? What will be the value of this H2? How much?
2.
2. But there are how many? 2. That means 2 into 2. How much? 4U. And what is oxygen?
16.
Huh? One oxygen is 16. There are two oxygens.
32.
32U. And what they are producing? How much in terms of the mass? How much mass of water will be produced?
36U.
How much?
36U.
2 into 18 is equal to 36U. So you are saying, students, that 4U hydrogen H2 combines with 32U oxygen and they produce 36U of H2O. And now I am saying U is equal to how much? 1U is equal to how much? 1.610 minus 24 gram. Now, can I use this calculation, students? Is it a convenient number? Is a U a convenient number?
No, sir.
So, U for calculations, what I'm trying to say, students, when I will do the calculations for any chemical reaction in chemistry, I need some number which is convenient to use. This is not a convenient number. So here started the search for a number, that we must not use molecules, we must not use atoms, student, when we are doing calculations, because it is not possible. And how the problem was solved, student, in chemistry? If I do any reaction, what I use? Do I use U or I use something else, student? Do I talk of one molecule? Do I talk of 5 molecules are produced, or I talk of something else? Do you have any idea, student? So how do we solve this problem, student? These numbers are very, very small. 1 U is equal to 1.610 minus 24 gram or 10 minus 27 kg. We cannot handle this in our calculations, and we cannot say, okay, 4 U hydrogen is combining with 32 U of this to produce 36 U of water. This is not a convenient scale, student. And you already know, in order to solve this, a concept was given which is called mole concept, student. A number is introduced, student. That number is a mole. But I am saying, what is a mole, student? In order to solve this problem, they define moles of the substance, not molecules of the substance. In order for calculations to make convenient and simple, what we use in chemistry, moles. In other words, student, I am introducing a new concept, which I am saying mole concept. Now what I am talking, mole concept. Instead of this 2 molecules of this, I am saying 2 moles of hydrogen. 2 moles of hydrogen combines with 1 mole of oxygen, student, to produce 2 moles of H2. So from molecules, student, I am coming to moles. But I am coming from molecules to moles. This is a very important concept now. You understood? Now we are trying to use, instead of the molecules, I am using mole, and mole, student. But then what is a mole? What is a mole, student? This quantity was experimentally determined actually. For the case of carbon 12, the mass of carbon 12 is how much? 12 U. So they determined this quantity for 1 mole of the carbon. And 1 mole is only a number, student. Just like you have 1 dozen. 1 dozen is how much? 12.
Yes, sir.
So if I say 100 means 100 times. So they defined a number 1 mole, student. They defined a concept mole in order to make our calculation convenient, which can be done in our daily life when we will perform the different type of chemical reactions. And 1 mole is a numerical value, is a number which is equal to 6.022. Here is a value of this into 10 power 23 particles. What is a particle, student? I have 12. Supposing I have bananas 12. That means 1 dozen of banana you are saying. So I can say banana are my particles. When I say 1 mole of banana, how many bananas will be there? How many bananas will be there? 6.022 10 power 23. If I say one mole of apples, how many will be there? 6.022 10 power 23. We may consider a whole number, then 6 into 10 power 20. So this is what we define as a mole. And in order to honor the scientist, Italian scientist Avogadro was a great scientist. They have given this number also the name Avogadro's number. Avogadro's number. This is also called Avogadro's number. Now you are clear, student, what is the use of mole concept? Why we are using mole concept? If we have to perform any reaction, if we have to do any calculation, if we are preparing any compound, then we will talk of how many moles of the compounds you want. And I will convert the moles into grams or kilograms, which is a scale which I am aware of already. So students, this is the idea. What I am talking now, mole concept, it should be clear to us. Number of particles. What particles can be there? It can be atoms, molecules, or ions. What is anything made up of? Atoms or molecules or ions. Ions, you have been seen. What are ions? They have positive or negative charge. Present in 1 mole of a substance. This value is fixed. How much? 6.022 10 power 23. Have you noted this number, students?
Yes, sir.
This is experimentally obtained value. The number is called Avogadro constant. Avogadro, because Avogadro is a scientist, was a scientist on the name of which it is given, is represented by NO Avogadro's number, named in honor of Italian scientist Emilio Avogadro. 1 mole of anything will be how much? 6.022 10 power 23. It is only a number, student. It is an amount. And this value is how much? 6.022 10 power 23. Now what the number is doing, it is a magic number. Let me see why I said that, student. What is the importance of this? You see that you are saying for hydrogen atom, student, this is a hydrogen atom. Okay? What is its mass in U? Tell me. 1 U?
Yes, sir.
How many grams? How many grams? I told you 1 U. 1.66 into 10 minus how many?
24 grams.
24 grams, student. This is a very small number. If I say instead of 1, this is the mass of 1 hydrogen atom. Mass of 1 hydrogen atom. Is it clear?
Yes.
Now I say 1 mole of hydrogen atom. Then what will be the mass of 1 mole of hydrogen atom, student? Multiply with 10 power 23 into 1.66 into 10 minus 24 gram. Find the value of this, how much it is coming, and tell me. Tell me, student, what is the answer you are getting? How to calculate? Easy. I will take the 6.022 into 1.66 together. And what is this? 10 minus 24 and 10 power 23. What will be that? 10 minus 1. So what is the answer coming, students? Multiply 6 into 1.66.
9.98552.
9.98
98552.
552 divided by this 10. Okay? 9. This you have multiplied with this also. After that?
No, sir.
Huh? Divided by 10. Almost it will come equal to 1 gram. Am I right?
Yes, sir.
So student, very important thing, very important result. I'm saying the mass of 1 atom of hydrogen, 1 atom of hydrogen is 1 U, and mass of 1 mole of hydrogen is how much? 1 gram. Interesting. A very important result. 1 gram is a number which is a convenient number for me in calculations. Grams. Are you used to grams?
Yes, sir.
Okay. Similarly, students, if I say mass of 1 molecule of H2O, how much is that? 18 U. Okay?
Yes, sir.
18 U. And student, which is equal to 18 into 1.66 into 10 minus 24 gram. Am I right?
Yes, sir.
And if I say calculate the mass of 1 mole of H2O, how will you do that? What will you do? We already defined 1 mole is equal to how much? 6.022 into 10 power 23 particles. It is a number. Multiply this with what number?
18 into 1.66.
10 power 23 into 18 into 1.66 into 10 minus 24. Find the value, student. What is the answer coming? What is the answer?
29.88 into 6.022. 2 8 the 16, 2 8 the 16, 7. 6 4 4 3 4 8 6 are 48, 48 plus 4 52, 9 6 are 54, 54 plus 5 59, 6 12 plus 17. तो ये हो गया 6 13 17 14 13 3 9. ये हो गया देखो 5 डेसिमल प्लेसेस.
What was that? Student, you have to be smart. Just now I have calculated the mass of one of this. So why you are doing so much a calculation, student? If I take 18 separately and if I take 6.022 into 1.66, 1.66, what happens? 10 minus into 10 minus 23 and minus 24, 10 minus 1, student. This value you have already calculated. You just calculated this value. How much was it? We calculated this value just now. What is the issue? What is the problem? Why you are making such a big calculation? See, this is what we say, by practice and by experience, student, we answer so many questions. Try to see what answer you are getting now. It is easy. Why we are making it difficult? We should be smart in doing the calculation, student. This value is how much? But I calculated this whole number. We have calculated this value. Here, what was that? What is that? 1?
Yes, sir.
So 18 into 1, how much will be that?
18.
Interesting. One molecule of mass of 1 molecule of water 18 U and mass of 1 mole of water 18 grams. So what is happening? The U are converted into grams. When I use 1 mole, when I use 1 mole, what happens? So we are saying if mass of C12 is 12 U, okay, then one atom. And if I say 1 mole of C, how much will be it? Equal to 12 grams. Equal to 12 grams. Clear?
Yes.
So by using the mole, students, mole number 6.022 10 power 23, what we are able to do, convert U into grams. So I can say the mass of 1 mole of atom of element is the molar mass. So we are defining, what I am defining, student, molar mass, which is molar mass. Molar mass means mass of 1 mole. Mass of 1 mole of element. Mass of 1 mole of element will be equal to, numerically equal to what? Molar mass or mass of 1 mole of element will be numerical equal to what? Change the units from U to grams. Okay? Change U to grams. Unit to grams. That will be the mass of 1 mole of the element. Or if I have compound, then that will be the molecular mass. What we call it? This is called the atomic mass. So we can say if I have a hydrogen atom, student, the atomic mass of hydrogen is, or I can also call it, or gram atomic mass. I can also call it gram atomic mass, student. How much it will be? Gram atomic mass. That will be the mass of 1 mole of the hydrogen atom. Mass of 1 mole hydrogen atom, it will be equal to how much? 1 gram. Clear? So if I say, in other words, I am trying to say that the 1 atom of oxygen mass is how much, student? 1 atom of oxygen mass, tell me how much? What is the mass of 1 atom of oxygen? We have given you
16
U. And if I say 1 mole of oxygen, how much will be the mass? 16 gram. Is it clear? All we have to do is convert U into grams. We get the atomic. This is what we call as a atomic mass or gram atomic mass. A table is given in the book, or if we have molecules, we say molecular mass. Molecular mass. The table of molecular mass are always given in terms of grams per mole. They are given in terms of grams per mole. If I say copper, 63.5 gram per mole, student, the short symbol of mole is MOL. Mole is written as MOL, student, and this is a SI unit of the amount. Important point. Mole is SI unit. What is the SI unit, student? Standard International Unit of what? Amount of the substance. Amount of substance. Internationally, it is accepted unit. Standard unit. So note down everything. Important questions will be there like this. What is a mole then? It's a number. How much it equals to? 6.022 10 power 23. And 1 mole is equal to how much? 12 gram of carbon. 12 gram of carbon. And if I say for O2, 1 mole will be equal to 32 gram of oxygen. 32 gram of oxygen. And 1 mole contains how many particles? 6.022 into 10 power 23. And this is accepted as SI unit by International Union. SI unit, standard international units. There are 6 standard international units, and this is nothing but gives us the amount of the substance. So in chemical reactions, what we will be using? Tell me, U or mole? What do you want? Huh? Mole. So what will mole show? If I have 2 moles, so that will be equal to the molecular mass into 2. And that amount will come in grams. What I'm saying, gram per mole. That's also we call gram atomic moles. That is what we are trying to say. I hope the idea of mole is very clear, because students have a lot of doubts in this. I am taking so much time to explain to you, student. If you have doubt, you can ask me. For the same time, I am going to say, oh, water, heal me. I will sip water. All right. Now you have got the idea that why do we use mole concept in chemistry. All the calculations in chemistry, all the chemical reactions which we are doing, students, we will be talking in terms of moles. So we are now saying that 2 molecules of hydrogen are reacting with 1 molecule of oxygen to form 2 molecules of water. I am saying 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of H2. That's what I am saying.
Yes, sir.
Clear? And
yes, sir.
Okay. So that is the idea what we are saying. We are using, student. So that means I can say, student, in this reaction, I am saying 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. Or in other words, what will be the mass of 2 moles of hydrogen? What will be that? 2 into 2. That will be equal to 4 gram of hydrogen. Okay? How much hydrogen? 4 gram of hydrogen, students. Reacting with how much? How many grams of oxygen now? What is 16 into 2? 32 grams of oxygen. And what is the product, student? 2 into 18, 36 gram of H2. So students, when 2 moles of hydrogen will react with 1 mole of oxygen, how many grams of water will be produced? 36 grams. And if I say 100 moles of hydrogen are reacting, then 50 mole of oxygen will be used. And you will produce 100 moles of water. So what will be the mass of 100 moles of water? 100 into 18. How much? 1800. Yes, 1800 grams means how many kilogram?
1.8 kg.
So 1.8 kg is a good number. What is the problem in dealing with these numbers? Do you have any? So calculations are becoming very convenient, and we can convert moles into grams and grams into moles. And we also know what is the number of particles which are present in 1 mole. So note down everything, very important. Okay, student, I hope you understood what I said. I said the mass. Now let me read another statement. Whatever I said here, again I'm reading. Mass of 1 mole of substance is equal to relative atomic or molecular mass in grams. The atomic mass of an element gives us the mass of one atom of that element in U, atomic mass unit. To get the mass of one mole of atom of that is the molar mass, and is in numerical value, but change the units from U to G. Clear? What we did? Convert U into G, it will become the molar mass in grams. Molar mass of atom is also known as gram atomic mass. For example, atomic mass of hydrogen 1 U and gram atomic mass 1 gram. 1 gram of hydrogen means how much? 1 mole of hydrogen. 1 U hydrogen has only one atom. 1 gram of hydrogen has how much? 1 mole atoms. And how many atoms will be there in 1 gram atom of hydrogen? Avogadro's number. This is our Avogadro's number, which we represented by this. Avogadro's number. Is it clear?
Yes, sir.
Which is equal to 6.2. So 16 U means 1 atom of oxygen, and 16 gram of oxygen means 1 mole of oxygen. 1 mole will have how many particles of oxygen? 6.022 10 power 23 atoms of oxygen. Are the ideas clear, student? Any doubt now in mole concept? This is the most important thing, because here students have a lot of confusion. If we don't understand, we will have a lot of difficulty in other higher classes, because there will be calculations based on this. Again and again saying, if any doubt is there, student, you can ask it. I have tried to show it completely. Everything has been shown to you in a very easy way. That how do we make the calculations, and when one atom is there, that is the U, and when 1 mole is there, then it gets converted into gram. That was the reason we used mole as equal to 6.022 10 power 23 particles. The particles can be anything. Atoms, molecules, ions, anything. Molecules, carbon dioxide, 1 mole of CO2 will mean how much? There will be 6.022 10 power 23 molecules of carbon dioxide in the compound. Is it clear? Is it clear, students?
Yes, sir.
All right. So far, so good. This is where we are working now, because there will be questions based on mole concept always in every exam. There will be no exam where there will not be question asked on it. And 9th, 10th, 11th, 12th, as I say, that our video lectures, our notes are going to be good for you as long as you study in your life. There is no end. Because basic concepts are being explained in a very simple and clear way. And you can use them, no problem which class you are, college class, higher class, anywhere you will use these numbers. So it is better for you to have a, as I say, subscribe the channel so that you can get very valuable information on different topics of science. And then we will be discussing higher levels of chemistry and many other subjects also, which will be finding useful in higher classes, as students from college are also taking classes from me in chemistry and other subjects. Those my students who have already passed, some of them are in colleges, in different universities, and they still come with me to me for some chemistry, and I'm helping them. See, this is the situation. That's what I'm trying to say, that I am also a learner like you. I'm also a student like you, and I learn from teaching, so I do that. As I will be writing a lot of books also, and not only on science, on some other things also. As you have seen me, I am working and doing research on science of life students, where I talk a lot about breathing exercises, meditation, yoga, running, jogging, so many things I do. So this is a part of what I do, and I always propagate all these ideas to the students so that they can change their life, they can transform their life for better, for better, for better. In a very, very simple and easy way. There should be no stress. There should be no pressure. There should be no tension. That's why we talked of attitude of gratitude. We are thankful to everyone for all the things we have. And you know, all over the world, people are dying and starving also. Have you seen pictures of storms and floods and droughts? And in certain countries, you have seen violence and all these things you have experienced. So we are happy, at least we are comfortable. Am I right? So
yes, sir.
You are still studying peacefully. There are places where there is no peace. All right. So I hope this whole word by word and line by line concept is very clear, student. What is a mole concept? Now, We are going to give you a table which will help us in numericals. So for solving, student, because mole concept will be mainly used for calculations. Why did we brought this? So that our calculations in chemical reactions become easy and convenient. So when I say, student, mole, and you said ki 1 mole is equal to 6.022 10 power 23 particles. It could be atoms, ions, or molecules. So when I'm saying, if I have 1 mole of carbon, what I'm trying to show here, if I have 1 mole carbon atom, student, how many particles are there? 1 mole of carbon atom, what is the mass? Gram atomic mass. What is the gram atomic mass of carbon now? 12 grams. Okay? For 1 atom, I said 12 U. Now I'm writing 12 grams. And how many particles it contains? 6.02 into 10 power 23 atoms of carbon are there. How many atoms are there in this? So 1 mole of atom of carbon will contain how many atoms? 6.02 10 power 23, and the mass will be 12. 12. I'm saying, student, I'm just saying like this, student. If I take 1 mole of carbon, student, how many grams it will weigh? Tell me. How many gram it will weigh, student? I am saying on the table I am putting 1 mole of carbon. Tell me how many gram it will be?
12 gram.
12 grams. 12 grams. How many atoms will be there in this? 23 atoms of carbon. Now you can see how many are there. Very large number of atoms are there in 12 gram of carbon. If I put a powder of carbon here, 12 gram. Now, student, I am saying I am putting 1 mole of sulfur. Can you tell me what will be the weight mass of this? What will be the gram atomic mass, student? Mass of 1 mole of sulfur. How much is that? How much is that? There is a table which is given in the book, student. How much is that?
32 gram.
32 grams, student. And it will contain how many atoms of sulfur?
6.022 into 10 raised to power
23 atoms of sulfur, student. Now I'm saying I'm putting here 1 mole of copper. How much will be the mass of 1 mole of copper, student? To check the value of the gram atomic mass of copper. How much it is coming? 63.5 gram. And how many atoms of copper will be there? 23 atoms of copper. Is it right?
Yes, sir.
Now I'm saying I'm putting 1 mole of Zn. What is the atomic mass of zinc, student? We have to check this in the table. We can't remember all the things. So let me give you. You know why the fractions are there? These are average atomic masses because there are isotopes. How many atoms will be there? Same?
Yes.
Same.
6.022.
Atoms. Same number of atoms. What we are trying to see, student, that different elements now, you can see they have different masses. As you will put a student, if I give you 1 mole of zinc, 1 mole of copper, 1 mole of sulfur, 1 mole of carbon, I said, okay, pick up. Which will be the heaviest out of all this? Which will be the heaviest?
Sir, 1 mole of zinc.
So 1 mole of zinc will be heaviest. And you will see in the periodic table, in the atomic weight scale, there are some elements which are very, very heavy. So if I give you 1 mole, then you will find, oh, its weight is very heavy, because their atomic mass is very high and large, student. Atomic mass is very high and large. So 1 mole of that substance, if I put different 1 mole of different substances, you see that they will weigh different amounts. Lead is heavier. Lead is heavier, even the atomic mass. So we have to check the list of the atomic mass, which is given in some of the books. You will see how heavy 1 mole of a atom will be, element will be, depending on the student. Ultimately, in the next chapter of atomic structure, will tell you where the mass is coming from, because atom is made up of subatomic particles, protons, neutrons, and electrons. Proton, neutrons, and electron. The sum of all this will make mass of one atom, or when an element is there, different elements have different number of protons, neutrons, and electrons. So when we will add this, that will give us the mass. And important thing, if I give you some information more, the mass of proton is almost equal to mass of neutron, which is equal to 1 U. 1 U. If I will take 1 mole, mass of 1 proton, I am saying, a mass of 1 neutron. Okay? If I take 1 mole, then it will become equal to 1 gram, right?
Yes, sir.
And mass of electron is negligible. Mass of electron, you know that proton, neutron, and electrons are present in the atom. Mass of electron is 1 by 2000 times that of mass of proton or neutron. Mass of proton or neutron. See, this is very, very small mass, which will be equal to how many U? 0.0005 U. So we neglect the mass of electron in most of the calculations. That's why we say mass. We will define another term which we will call as mass number. Mass is equal to mass of proton plus neutron. These are the numbers which I am giving because they will help you in understanding all this what I am talking. All the things which we are talking. So student, 1 mole of, if I take 1 mole of hydrogen atom, that is 1 gram of the hydrogen atom. And how many atoms are there? 6.02 to 10 power 23. In other words, I can say 1 mole of any particle or atoms is equal to 6.02 number of particles and relative mass of those particles in grams. What we call relative atomic mass or relative molecular mass. Okay? And 1 mole of molecules is how many? Molecule is formed from 2 things, elements or different elements. Different elements, when water is there, elements are different. So if I say 1 mole of H2O, that is a molecule of a compound. And what is the molecular mass in grams then? What is the molecular mass in gram here? Tell me. How much is it? 2 plus 16, 18 grams. And how many particles are there?
6.022 into 10 raised to power 20.
6.02 10 power 23. Okay, molecules will be there. Molecules of H2O. So if I say student, you are given 360 gram of H2O. Okay? Find the moles and number of molecules in H2O, in 360 gram of H2O. You have 2 minutes to answer the question. All this we are using, student. The more we do, the better we learn, student. That is the most important part. How much we can learn, that is the point. How much we can learn, that is the point, students. How will you find the moles? Moles of water. And I'm using N as the moles of water. If I have mass of water, H2O divided by molar mass of water, molar mass of water. What is the mass given? How much is
360 grams.
360 grams, student. What is the molar mass of water?
18 grams.
18 gram per mole. We have to write the units. Then gram and gram cancels. What do you get? How much you are getting?
20 mole.
20 moles of water. This is a symbol of the mole. How many molecules will be there? 20 into 10 power 23 molecules of H2O. How much it comes, student? See how we solve the questions. How we solve the questions. Therefore, we are now coming to more important things, that if the moles, if you have to find student moles and that the mass in grams, student divided by gram atomic or molecular mass. So M, I'm using a symbol now, M by M, where N is the moles. M is the, what is M, student? M is the given mass in grams. And what is M, student? Molar mass. Okay? It becomes a good formula for calculations. Am I right?
Yes, sir.
So supposing, student, if I say that you have 88 gram of CO2, find the moles and number of molecules of CO2. You have 1 to 2 minutes to answer the question. How will you answer? Moles, how will it be? Mass in grams. What is mass? 88. What is the molecular mass of CO2? What do you get?
2 moles.
2 mole. And how many molecules will be there?
2 into 6.022 into 10 raised to the 23.
Molecules of CO2. What is the answer coming? So I may say 12 into 10 power 23 molecules of CO2. Am I clear? So
Yes, sir.
now we are able to do the calculations which were becoming difficult if I use the U scale. But if I use the moles, then our problem is solved. That is the whole game of mole concept. That is why I talked so much and explained to you. So I hope the lesson is clear, and that is what I have done my job in explaining to you so clearly. Recorded videos will be provided which will help you for any class. Keep on sharing our videos with your friends. Ask them to subscribe the channel. We are trying our best to explain everything in as simple a manner as possible. Bye bye. Then I see you in the next class.
Thank you, sir.